friends, it's Emma. So today I have a little bit of a different video for you. So whether you're here to just hang out, learn something for the first time, or need a little bit of a refresher, this is the place for you. Today we're going to be learning about carbohydrates and a few other things. All of my script I got from either the Miller and Levine Biology textbook or my biology notes that I got from my teacher. Thank you, Mrs. Anderson. Anyways, so just to kind of show my credibility, I got this script approved by my dad, who's a radiologist, so he took classes on all this fun stuff. And then I also got the script approved by my biology teacher, this is what she does. So thank you so much for everyone who helped out and helped make this script as true to science as it can be. Firstly, we have to talk about the backbone of all organic chemistry, which is carbon. Carbon is found in all living things, and it's so important that it even has its own branch of chemistry, organic chemistry. The reason carbon is so important is not only because it's found in all living things, but it has 4 valence electrons, giving it the ability to make so many different kinds of covalent bonds with other carbon atoms. A few examples are creating long chains or rings of carbon, and in these long chains, they can form single, double, and even triple bonds. Now let's say some carbon and hydrogen atoms have made an arrangement, like glucose. But it's also possible for carbon, hydrogen, and oxygen atoms to form fructose and galactose. How is this possible? Although these molecules have the same types of atoms, they have different structural formulas. This is called an isomer. Because isomers have different structural formulas, they have different properties. If thousands and thousands of molecules come together, then they form macromolecules. The process of forming these macromolecules is called polymerization, where to form a macromolecule, small units of monomers come together to form polymers. These monomers can be of the same molecule or different. But to make all these mers a bit easier to understand, scientists split them up into all these organic molecules into 4 different groups: carbohydrates, which we'll be talking about today, lipids, nucleic acids, and proteins. So what is a carbohydrate? When you think of a carbohydrate, you may think of pasta, bread, potatoes, but fruit and some other sweet things can be classified as a carbohydrate too. So let's get a little more up close and personal. Not me, cue the slide. A carbohydrate is made of carbon, hydrogen, and oxygen atoms. In most cases, for every oxygen atom, there are 2 hydrogen atoms. So what purpose does carbohydrates serve to living things? Okay, so if you remember, there was this bad diet of having no carbs. This diet would help you lose the weight, but it would take a very ugly turn. People who went on these diets, body chemistry would be messed up and there were some really scary side effects. And this is because carbohydrates are used as our main energy source and sometimes for structural purposes in other organisms. So, do you get why excluding carbs is a bad idea? We get energy from carbohydrates and the sugars breaking down. And the sugars that we don't use immediately are stored as starch for later. And if we go back a few steps, starch is a polymer made up of several sugar monomers. Back to monomer talk. Single monomer sugars have a special name, monosaccharides, which is like glucose, galactose, and fructose. Now, let's say we have 2 sugars. That would be classified as a disaccharide. And like in its name, di means 2. So a disaccharide in real life would be like sucrose, which is glucose and fructose, which is table sugar, or lactose, which is glucose and galactose, which makes milk, or maltose, which is glucose and glucose, which makes beer. Finally, the last type of saccharide is a polysaccharide, which is many sugars, or in a shorter term, starches. There are 3 types of starches: glycogen, which is animal starch or liver and muscle, plant starch, and cellulose, which is plant fibers, so like wood and paper, stuff we can't eat. Now the final topic I will be discussing is polymerization. Polymers are formed when hydrogen and OH groups are removed from monomers. So in order for carbohydrates to form polymers, a hydrogen and OH is removed from the molecule, which forms water. This process can be called dehydration or condensation synthesis because water is being removed. Now, the opposite of dehydration is when large molecules split into smaller ones because water molecules are being added. This is called hydrolysis. So, like how OH and hydrogen have been taken out of the polymer, it's like we're reversing that with hydrolysis. An example of hydrolysis is in digestion. So let's say a potato is broken down in the stomach and the sugars are used and the starches are stored for later. So that's all you need to know for carbohydrates. Or if you're near my class, hey guys, for the introduction of 2.3, and again, all about carbohydrates. To summarize, I talked about carbon and how it's the backbone of life, the chemistry of carbon, isomers, macromolecules, carbohydrates, monosaccharides, disaccharides, polysaccharides, condensation synthesis or dehydration, and hydrolysis. I hope this helped clear up a few things for you. Now, just to restate, I got my information from the Levine Biology textbook and my biology teacher and her notes. So now, after carving up on your carbs, go forth and spread your knowledge. Bye guys!